Okay, so welcome to another video for the graph theory plan that we were doing. Today's problem is 1254 number of closed islands. So I'll just read the problem statement and then we'll discuss the solution approach and then write the code and come up with the space and time complexity for the code. So it has been asked in Google, Microsoft, and Amazon. So it's a very common interview problem. So within the last 6 months, it has been asked in Google. So you get the hang of it, okay? So basically, this is one of the important graph problems that one needs to do, okay? So I'll just read the problem statement. So problem statement says that so you are given a 2D grid, okay? Given a 2D grid consisting of zeros and land. So one thing that you need to see as compared to a previous graph problems, the zeros here are representing land, not the one, okay? So ones are representing water. That is the slight change that they have done in this problem. An island is a maximal four directionally connected group of zeros. So what it says is just keep connecting zeros in all the four directions, and whatever you get is whatever entity that you get is an island. And there is a definition for a closed island as well, which is totally surrounded by ones. So in this case, this particular island is totally surrounded by ones. Okay. These two are not totally surrounded by ones. Okay. So these are not counted as in the result. This zero is itself an island of unit 1 area and it is surrounded by one on all four sides. So it will be counted as closed island. So there are two closed islands. Okay. So similarly here as well, there is one closed island and these are not the closed islands because these are lying on the boundary and they are not completely surrounded by ones. So let's start with the solution approach. Let me open the whiteboard and then we'll try to first of all uh, create the grid. Okay. Let me move back and open a new whiteboard and we will use black. Okay. First of all, let's draw the grid. We'll take the first example itself. It's a big grid, so it says 7 times 1 and then 0. Okay, so in this case, we will also mark the closed islands, which is this one is a closed island. Similarly, there is another closed island. Totally surrounded by one's four sides. Okay, so let's discuss the approach. Okay, so again we'll start iterating through the grid. Okay, and we'll only process according to the logic. that will help us arrive at the correct solution. So we know the closed island number of closed island we need to find. Okay. Yeah. Let's write that down. Return number of closed islands. Okay. So we know that closed island will be consisting of zeros for sure, and those zeros shouldn't occur at the boundaries. That is the ultimate criteria. So closed island will always consist of zeros, and those zeros will not be at the boundary. Okay. So again we will start loop from 0 0. Okay. If it is 1, skip it because it is water. Okay. If it is 0, perform DFS, but maintain a flag that becomes, you can say true or false. Okay, but let's see, that becomes false if there is a 0 in the current island uh, that lies on boundary. Okay. So in other words, what I'm trying to say is, if it is 1, skip it simply because it is water. It's no use of to us at all. Okay. We want to find uh, closed islands. If it is 0, what we need to do is we need to check. For example, if we take the example of this particular 0, if it is at the boundary, then so basically, even in this case, we will perform DFS. DFS will give us this island. Let me use another color. So we will skip all these ones and then we will come here and we'll perform DFS and it will find an island. Okay. So when we come to the 0, we will perform DFS, but we will also we are also maintaining a flag here. Okay, which will become false if the zeros contained in this island lies on the boundary. So in this case, it is, although it is an island, but it is not a closed island. Okay. So this is what we will do, and now we'll write the code for this. Okay. Let me move it like this so that we can still see the grid. Okay, while we write the code. So look at the function. It says, let me change it. Public int, and we are given a grid. So the template that we'll follow is similar to previous questions of the graph theory plan that we have done. First of all, we need to store the m and n values. Mm, Okay. Again, we can, so we have to mark the visited nodes as well. Again, what we can do is we can, if you haven't looked at the previous videos of the graph theory plan, of the graph theory playlist, it's a good idea to check them out because it contains the similar kind of approach that we'll be using here. Okay. So, again, we are faced with the problem that how to maintain, how to find whether particular cell has been visited or not. For example, if you perform DFS on this zero, it will visit these all zeros, okay? So when while looping, if you come back to this one, it has already been visited and it's known to be a part of this island. So we need to avoid that revisiting. So ultimately, we need some kind of mechanism to keep track of the visited nodes in this particular grid. How we can do it? There are again two ways. Either modify the value of the cell itself. For example, modify it to from 0 to 2, mark as visited. Or you can maintain a Boolean visited array as well. Okay. Let's try to go with the Boolean approach because we can anyway translate it to this kind of approach, second approach, very quickly. Okay, so I will just write a Boolean visited array. Okay, this has been also initialized now. Another thing that we need, if you remember from the approach that we have discussed, sorry, we also need a flag variable, which will tell us whether a particular island is a closed one or not a closed one. So in this case, again, I'm using a Boolean variable, but you can use an integer variable as well. So again, I want to pass this by reference. I don't want my flag value to change while it is going through recursion or different calls of recursion. So in order to make sure that a variable value doesn't change in a recursive call, we need to pass that variable as a reference or use a global variable, whichever way you prefer. I do it like this. So arrays are always passed by reference. So I use a size 1 array that will store the, so as a comment, it will tell whether a particular island is a closed one or not. Okay. It will return true if it is a closed island. Got it? So, and we also need to count these islands, right? So we need a counter. So in this case, we can just directly initialize count closed island variable to 0. Now we will loop over the grid. All the variables are now declared. I think I less than m. Okay. Okay, so what is the criteria to visit or not visit, okay, particular node? So if grid ij, we should only go into if it is not equal to 1. And visited ij should not be true. Okay, only then we should actually visit and perform the DFS on this. Only then it is an unvisited zero uh, in the particular grid. So now we will write DFS. We will implement this function. uh, Nothing to worry about this. Let's provide the ij values, and we also need to provide visited along with flag. But before providing flag, what we need is we need to initialize flag to 0. Sorry, true, because of this thing. Okay, it should return true if it is a closed island. So we know this flag 0 will become false according to the condition that we write in this function implementation. It will become false when we find one of the zeros of any island that lies on the boundary. Only then it will become false. So we will just come to that. But for now, just understand that this is how it looks like. And one more condition that I missed was counter. Okay, if flag 0 is true, count plus plus. Okay, this is how it looks. Now we just need to write the code for DFS. Implement this code. Okay, so static void DFS. Again, you can write the correct code like this: integer r, integer column value. So I am also writing the syntactically correct uh, code flag. Okay. Again, the boundary conditions. If r is 0 or if r is greater than or equal to grid, actually even equal to should work, but just for safety purpose we are doing this so that we can make sure that uh, in any case it should not exceed the boundary conditions. Or now we will not simply return, we will change the flag value to false before returning here, because what this says is one of the zeros lie on boundary. But wait a minute, while if we go to the grid again, so let's say if we start from here, okay, if we start the DFS on this one, it will perform DFS in 4 directions. But what will happen is it will also go into this direction and encounter 1. which is the criteria that we have missed. Yes, it's fine because it will go out of boundary conditions only when if it is at the boundary element. So only for these zeros it will try to go outside of the limits. Otherwise it will come to either 1, okay, or 0. So if it comes to 1, we will write a condition, exit condition for this one, okay? This kind of one, which is at the boundary. And for zeros, we have already written, we are already, so when we perform a DFS on such a zero, it will try to go outside of the limits. So we know for sure that this zero lies on the boundary. Only then it will try to go out of bounds. So that's why before returning, so obviously we will not go out of bounds, but before returning, we'll make sure that we are storing the flag value as false because this is not a closed island at all. Now let's write another exit condition. So this will be about what happens if it comes to 1. Okay. So again, we won't be processing that. So if grade ij, if it is 1 or if it has been visited, return. Now just mark the current visited node. So just use R and C value instead of. So I in hurry I wrote ing, but you understand it, right? So RC equal to true and now perform DFS like previous problems on all four directionally adjacent elements. So you will write this 4 times and then close this function. But pass the arguments like this. Rest of the arguments will remain same. C plus 1 or C minus 1. Rest will remain same. Okay. Now let's write the same code on the editor as well. So I'm not applying any brain, I'm just copying whatever approach that I shared, okay? I will apply my brain only when it fails, okay? If there is this approach fails or there is some debug issue that I need to do. for this, flag value should be set to true every time. And if after doing this DFS and finding an island, still the flag value remains true, what it means is there is none of the zeros in this particular island that lies on the boundary. Okay, so that's what it means. So in that case, we will increment the count. Okay, that's all I think. Yeah, and at the end, return count sub-islands. Now let's write DFS. If it is water, or if it has already been visited, then also we should return. Now we process the actual zero. So all the return conditions have not been met. So we are at the unvisited zero in the grid. So then we mark it as visited and then perform the DFS for all its neighbors. It should be r plus 1c visited flag. So this flag in each of the recursive call, I don't want its value to change. So that's why I supply one size one array to pass this value as a reference. Okay, arrays value. So in the this case, flag zero, flag zero, it won't change in each of the recursive call that I am passing it as an argument. So if it becomes false in some of the stage, so it will remain false for rest of them as well. You can approach this thing by using a global variable as well, as I mentioned previously, but again, it's depends on you. Just this, the only requirement is this flag value shouldn't change in each of the recursive calls. Okay. At the end, you can choose to write a return statement or skip it. Let's see, some issue will pop up. No, it's working fine as it is. Let's try to submit it. So it's accepted. Uh, Runtime 2 millisecond, memory 42.6 MB. I mean, it's decent solution, okay? But runtime still can be improved a little bit. Uh, what optimization that we can do over here is one of the approach that I can tell you is, yeah, one of the approach that I was trying to think of is get rid of this visited array. Just change the value of whatever element that you visit for and because the grid originally contains only 0 and 1, so if we have visited a certain element, we will mark it as 2. Okay, that is also another way to mark it as visited instead of using additional memory to store this information. So get rid of visited everywhere. So we are doing nothing, but instead of maintaining the whole same similar size grid of containing true and false values for each of the position that we have visited, whatever cell that I visit, I change its value to 2, so that I don't process it or visit it again. Okay, so that's the whole logic. Um, so let's get rid of visit. So what happened? Mm, Okay, yes. Okay. It's taking slightly more space instead, but yeah, again I mentioned right, these numbers depends on a lot of things, so just don't trust them like that. If I run it again, it will show some other metric. See, now it is taking 43.1. So basically those numbers cannot be trusted, but we know for sure we are not using additional memory here. We are only using a flag variable, okay? And we are just we keep changing the value to true for every island that we find, okay? And we have a counter basically that's also constant. It's not changing with the size of the grid. So time complexity. So we will visit all the nodes at max because we have a criteria to mark, not visit whatever we have visited once. So it will be O of mn. So that's my solution for this number of closed islands problem. Hopefully that was helpful for you guys. Let's try to solve yet another problem after this video. But yeah, it was an interesting problem. It has been asked in all of the major companies, FANG companies or MANG companies, whatever you want to say. But yeah, so very important. Yeah. So that's all for today's video. Okay, bye.